We're doing some fancy stuff here. So I'm Chris Cohen, this is Howard Brand. Howard Brand had the pleasure of coming out about a year ago, pre-market. We learned that the invention is the easy part of the equation. The refinement, the cross-testing, the mass balancing, the EPA, every regulatory environment in the world was the challenge. So we come back a year later, as we've had multiple firms try to prove us wrong, and they all proved us right, well-known national firms. Our largest advocate now is the EPA. They're excited for what we do because we solved a very large international problem. So instead of me talking about it, I'm going to let the video talk about it. Oh, before we start, Howard's going to do what he does, which is melt a shingle to show live exactly what happens, just on a very small scale.
This is an asphalt shingle. It's made up of three main parts: a fiberglass base, oil, and sand. 11 million tons of these are thrown away every year, placed into landfills, and potentially leach toxins into the land and subsequently our water supplies. That's a total of 924 million gallons of oil annually disposed in landfills. To put that into perspective, the biggest oil spill, the Deepwater Horizon, was estimated to be over 160 million gallons. This is a huge issue, but it doesn't have to be. Through our process, we can safely and without waste transform these shingles into high-grade sweet oil, usable fiberglass, and high-end sand. Throw out any idea of what you imagine this looks like, because this process is incredibly unique. Imagine a large washing machine. Yes, a washing machine. The shingles enter this machine, are then cleaned with a proprietary solution, and come out the other side into three main parts. No extra waste, all three are reused, repurposed, and resold. C6Zero, manufacturing for the future. This is an asphalt.
All right, there we go. So tens of millions of tons of these are thrown in US landfills every year. That doesn't sound like a big problem until you dig into the chemistry of what happens with that. Our friends and engineers that we have worked with from MIT tell us that the composting effect in landfills causes these to emit really bad gases that either air off or end up in ground soil, making their way into groundwater. Well, that's a really big deal, and that's why the EPA advocates what we do. Our solution cleanly and efficiently manufactures all of this into, per ton of asphalt shingle captured, a little over 2.3 barrels of oil to be blended currently in our launch operation into a biofuel, a B5, B10, or a B15, 0.75 yards of ATSM 33 aggregate. The roofing companies are pretty excited to get back. They spend a lot of money making it. And 12 pounds of clean fiberglass comes from every ton of asphalt shingles. There are over 4.6 tons of asphalt shingles on the average US roof, and globally, by over 60%, asphalt shingles are the common global roofing system. Market magnitude, we talked about this, over 11 million tons of waste shingles in the United States per year. EPA behind closed doors thinks it's almost 3 times that. That market is not being tapped at all today. In fact, every consumer in America is paying to put these into a landfill. What that means is that the 11 million ton figure, over 26 million barrels of end product is our potential. Over 8 million tons of the ATSM 33 and over 185,000 tons of clean fiberglass could be produced every year. So what's next? Well, we talked a little bit about where we were. So we spent a lot of time with our friends at the EPA. That's exciting if you've never had the chance to do that.
Very fun. Yeah,
very fun, right? The good outcome of that is they love what we do. They're excited, and they are permitting our first site in Iowa. Iowa is what we're here to talk about today. So in Q1, a little town called Marengo, Iowa, who was devastated economically and by a storm last year, has a vast opportunity for us with a high rate of unemployment and a factory that's just sitting there on a fresh rail spur that is on a UP line with a significant amount of people in the radius that we look for economic viability. So Iowa, the Marengo site, it's over 170,000 square foot facility. It's a fully environmentally controlled building, existing refreshed rail spur. They just redid it and never used it. We intend to put 4 of our production lines into this facility. And we, as I said, there's an ample labor market and there's over 73 million people within a 500-mile radius. What that equates to is about 15 million homes within that 500-mile radius. Why that matters is we transport all of our feedstock and our end goods via rail. On the Marengo site, what that means is we will have the opportunity to process over 1 million roofs per year, or 4.6 million tons of roofing potential stock per year. That means over 10 million barrels of recycled oil, over 3.5 million tons of ATSM 33 aggregate, and over 77,000 tons of fiberglass potential per year. So we're here to talk about what we're doing and elicit interest in helping us get there. We're going to create over 150 to over 250 jobs in Marengo, Iowa. The state's excited about that, community's excited about that, and we're excited about that. We'll be around here afterwards to chat with anybody that's interested.
Can you talk about the RIN credit for 30 seconds?
Oh yeah, the extra goodie. So RIN credits, if you're familiar with those, blending our recycled fuel with soy oil, which we've tested and done, produces a RIN credit potential for the entire barrel. And so we are about to launch our engineering against that, which we've been told we will get there. Our firm is engaged. They're launching that in December, and we expect to be a RIN credit producer by Q1 next year.
Awesome. Thank you, fellas.
Yep.